Welcome students to our online chemistry class. Our topic is alcohols, phenols and ether. Here we'll discuss the method of preparation of that alcohols by reduction of carbonyl compounds. Carbonyl compound means C double bond O compound. So here we'll discuss different carbonyl compound. First aldehyde means if at least one hydrogen is attached to C double bond O. Ketones means two alkyl groups are attached to C double bond O. So first reaction is by reduction of aldehydes and ketones. So this aldehyde on reduction by hydrogen, molecular hydrogen in presence of nickel, or we can use LiLH4 lithium aluminum hydride, or we can use sodium amalgam in presence of water NaHgH2O, or we can use sodium borohydride NaBH4. So this aldehyde gives primary alcohol while ketone gives secondary alcohol on reduction with these reactions. Let us see the reaction of aldehydes and ketone. So when acetaldehyde CH3CHO react with molecular hydrogen in presence of nickel, and if we heat the mixture, then what we get? We get CH3CH2OH, that is ethyl alcohol or ethanol, and this is a primary alcohol. Same change can be carried out with the help of atomic hydrogen. So we have to use NaHgH2O, sodium amalgam in presence of water instead of H2 oblique nickel. Only the reagent in the reaction is the change, the remaining things are same. Or we can use ketones such as dimethyl ketone, CH3 twice C double bond O, or can also be read CH3 C double bond O CH3. It reacts with molecular hydrogen in presence of nickel, and if we heat the mixture, what we get? CH3 twice CHOH, or CH3 CH3OH. So your product is isopropyl alcohol or propane 2-ol. So this alcohol is a secondary alcohol. So propane 2-ol or acetone, which is a ketone, on reduction gives propane 2-ol. So alcohol is secondary. Same change can be carried out by using atomic hydrogen, but reagent is NaHgH2, sodium amalgam in presence of water. Or these changes can be used. These changes can be carried out by using LiAlH4, lithium aluminum hydride, and H3O plus, that is hydrolysis in presence of acid. So this is about the conversion of aldehyde and ketones to carboxylic acid. Then we can try for another aldehydes and ketones and write down the product whether we obtain primary alcohol or secondary alcohol. Then next reaction is also a reduction. Third type of carbonyl compound is carboxylic acid. So functional group is dash COOH. So as your carboxylic acids are less reactive than aldehyde and ketone, we have to use strong reducing agent LiAlH4, lithium aluminum hydride, and if you use that reagent, it gives primary alcohol. For example, acetic acid CH3COH, IUPAC name is ethanoic acid, react with LiLH4, and then we hydrolysis this in presence of acid, that is H2 oblique H plus means H2O plus, then we get ethyl alcohol and water. So 4 hydrogen is added. Out of that, 2 hydrogens are added to C double bond O, and it gets converted to CH2, while the C double bond O oxygen gets converted to water because it reacts with 2 hydrogen. So your product is ethyl alcohol. You can write the reaction with another acids, but this LiAlH4 is expensive reagent. When you have to prepare your alcohol commercially, we can't prefer this process, and for that purpose, if we have to use the H2 oblique ranitidine or simple nickel or pyridine, that is we use for aldehyde and ketone, then you have to convert your acid into suitable compound, and which is that it is a ester. So what is the function group of ester? Dash C double one O dash. So here the reaction is given: acetic acid react with ethyl alcohol in presence of H plus. So you have to add H plus to the reaction, means use concentrated acid. Okay, like H2SO4. Then the OH of your acid and hydrogen of alcohol gives water, and the remaining part, that is C2H5, get attached to carbonyl carbon. So it is the product CH3CO part from your acid, and OC2H5 means OCH2CH3 part of your alcohol, that gives a product. That product is ester. In your general representation, R dash is attached to carbonyl carbon with oxygen and OH from your. So how it is removed? This OH from alcohol and the H from your, OH from acid and H from alcohol. Then we get your product H2O. Product is H2O. Here we obtain H2O. So in this way we can obtain your ester and water. So when ethyl alcohol treated with acetic acid, it gives ethyl acetate, and then that ethyl acetate, the IUPAC name, so 2 carbon acid is acetic acid, parent alkane is ethane, replace the word E by OIC acid, so acetic acid is also known as ethanoic acid. So CH3COO group is acetate, or it is also known as ethanoate according to IUPAC name, and C2H5 group is in front of your oxygen, so ethyl ethanoate is the IUPAC name of ethyl acetate, which on reduction in presence of nickel, and if we heat the mixture, we get ethyl alcohol as a product, because this C double bond O carbon get converted to CH2 carbon, and CH2O becomes CH2OH, and that oxygen gives OH. Here. Then, what is the advantage of this LiLH4 over H2 oblique nickel? One advantage is it cannot reduce the carbon-carbon double bond in your carbonyl compound. So, for example, but2 in enol CH3 CH double bond CH CH. If you use LiLH4 for such a aldehyde having a double bond, it reduces only carbonyl carbon, and it does not reduce carbon-carbon double bond, because if we observe the product, we observe that CH3 CH double bond CH CH2 OH. So there is a reduction of CHO into CH2OH. So we get a primary alcohol because it is aldehyde, and double bond between two carbon remain as it is. But if you use H2 oblique nickel, then it can also reduce this CH double bond CH because same reagent can be used for conversion of alkene into alkene. So that is not used here. We use LiLH4 and H3O plus. So that is the advantage of this lithium aluminum hydride. So it cannot reduce carbon-carbon double bond or olefinic bond, and it reduces only aldehyde and ketone. So when you have kept your carbon-carbon double bond in your compound as it is and only reduced to aldehyde and ketone functional group, then we prefer LiLH4. Then next reaction is by addition of Grignard reagent. So use Grignard reagent for conversion of your carbonyl compound into alcohol. So again remember that RMgX is the Grignard reagent, alkyl magnesium halide. It reacts with your carbonyl compound to give a complex in which that C double bond O gets converted to C single bond O. Your alkyl group is attached to carbonyl carbon because alkyl group is nucleophilic part of your Grignard reagent because it's more negative part of that region, as magnesium is more electropositive, carbon is more electronegative, and it will attack on electron deficient, electron-less carbon because oxygen is more electronegative than carbon. So delta negative charge over oxygen, delta positive charge over carbon, and reaction takes place in presence of dry ether. We get a complex in which the carbonyl carbon is attached to your alkyl group from Grignard region, and MgX part get attached to oxygen. So we get a unstable compound, and that is added or complex. It is written in square bracket, which on hydrolysis in presence of acid H2 oblique H plus or H2O plus, then simply you have to break between oxygen and Mg, and it will give. So you have to add water. So here you have to add H because oxygen is more electronegative of your complex, and OH is added here. So your product becomes RCOH plus MgXOH. Okay, and we get alcohol as a product. So this is the reaction. Let us see the different carbonyl compound and what we get by using that compound when Grignard reagent react with that. So first let us see, we choose a aldehyde. So for that purpose we have to use hydrogen. So if we take two hydrogen, your compound is HC double bond O, and your alkyl group is CH3 as a alkyl group for Grignard range. So this is the alkyl group from Grignard region. So to get your Grignard region react with carbonyl carbon, and there are two hydrogen. So your compound attached to carbonyl carbon. So your aldehyde is formaldehyde, or it is one carbon aldehyde is methanol, because one carbon alkene is methane, replace E by Al. React with CH3MgI. So now CH3 is attached to this C double bond O, and it gets converted to single. So we get CH3 from your Grignard region, and CH2O becomes OMgI. So here I have written that. So that is the adduct, because C double bond is attached with two hydrogen. This is CH2. And then if we break this OMgI by hydrolysis in presence of acid, this CH3 CH2O become OH, and MgI becomes MgIOH. So we get a ethyl alcohol or ethanol, that is primary alcohol, when we take formaldehyde as a product, as a reactant or aldehyde. Then instead of formaldehyde, if we take any aldehyde than formaldehyde, that means if you take one alkyl group attached to carbonyl carbon and another is hydrogen, so your compound becomes CH3 C double bond O H, that means acetaldehyde, or two carbon aldehyde is ethanol, react with CH3 MgI. So that is the Grignard reagent. So this CH3 is attached to this carbonyl carbon. This CH3 is attached to this C double bond O, and it is converted to C double single bond O. So CH3 is attached here. So there are two CH3 attached to C double bond O carbon. So CH3 CH, C double bond O gets converted to C single bond O, and MgI get attached to oxygen. So your complex becomes CH3 twice CHOMgI. Then on hydrolysis, simply break the oxygen magnesium bond and add hydrogen to oxygen, OH to MgI. So to get CH3 twice CHOH, and your product is isopropyl alcohol, because your OH carbon reacted to methyl groups, and the APE3 name is propane 2-ol. So it is a secondary. So when formaldehyde react with Grignard reagent, gives primary alcohol, and any other aldehyde react with Grignard reagent to give secondary. You can try for another aldehyde. In that case also you get secondary alcohol. That means OH is attached to that carbon which is attached to two different carbons. Then if we choose ketone as a reactant, means two alkyl groups are attached to carbonyl carbon, then it is a ketone. For example, CH3 C double bond O CH3. So your compound is CH3 twice C double bond O CH3 twice C double bond O, that is dimethyl ketone, react with CH3 MgI. So now your C double bond O carbon contain 3 CH3 groups, and C double bond O get converted to C single bond O Mgi. So your complex become CH3 thrice COMgi. Now we have to break OMg bond, add hydrogen to oxygen and OH to Mgi on acid hydrolysis. What do we get? CH3 thrice CO become OH. CH3 thrice COH plus MgIOH. So your alcohol is tertiary butyl alcohol because this carbon is attached to 3 methyl group, and the alcohol is tertiary butyl alcohol, or the class is tertiary alcohol, or IUPAC name is 2-methyl propane 2-ol. 2-methyl propane 2-ol. So if we choose ketone such as dimethyl ketone, then we get tertiary alcohol. So you can change these alkyl groups attached to carbonyl carbon and Grignard region and find out the different alcohols that you obtain. But remember that if you use a aldehyde as formaldehyde, react with any Grignard reagent, your final product is RCH2OH, and that is primary alcohol. If we choose any aldehyde other than formaldehyde, react with any Grignard reagent, then your product is secondary alcohol because OH is attached to that carbon having two alkyl groups. So product is secondary alcohol. And if we take ketone, react with any Grignard reagent, then we get a tertiary alcohol because OH carbon is attached to three alkyl groups. So this is the importance of this Grignard reagent. So can you distinguish between simple reaction and reaction with Grignard reagent? So if you observe here, in formaldehyde only one carbon is there, but in your alcohol there is more than one carbon. For example, check here. Formaldehyde react with methyl magnesium iodide, we get two carbon alcohol because, but in case of aldehyde, formaldehyde there is one carbon. Or if you take acetaldehyde, there are two carbon in your aldehyde, but in your product there are three carbon. So number of carbon atoms are increased. Or you can check in ketone also. It depends on your Grignard region, how many carbons are involved in that Grignard region. That number of carbons are increased in your alcohol. But if you take simple reduction by using H2 oblique nickel or LiLH4, acetaldehyde gives ethyl alcohol. Okay, and here acetaldehyde gives isopropyl. This is the importance of this range. When you have to prepare ethyl alcohol from acetaldehyde, use H2 oblique nickel, and when you have to prepare isopropyl alcohol from acetaldehyde, then use methyl magnesium iodide in presence of dry ether and then hydrolysis. So remember this is helpful for the board exam as well as CET. Then oxide react with Grignard reagent followed by acid hydrolysis. So here Grignard reagent RMgX react with, so here RMgX react with CH2 single bond CH2O. So it is the negative part, it will get attached to any carbon in this, and then this bond between carbon and oxygen shift to oxygen. Okay, so R is attached, so your bond becomes, this R is attached to CH2. Okay, and RCH2 single bond CH2 O minus, at O minus take this Mg X. So what do we get? you can this O minus to take this mgx. Okay, so O become OMGX. Okay, so R CH2 OMGX, that is a complex which on acid hydrolysis now break the oxygen magnesium bond and add hydrogen here and OH here. Okay, so to get R CH2 plus MgXOH. So in this way you can write the reaction. Then